Everyone. I'm going to take this time to go through the 7 questions on the sample test that I shared with you in class last time we met together. And let's go ahead and start right away with question number 1. So question number 1 is a question about bills of materials. And for this type of question, you'll be presented with this diagram, which shows typically an end item at the very top. Our level 0 item is that final product. Could be that this company is selling maybe bikes. And at the very top there, we have a bike. And this bike is made of different subcomponents. Okay. So the bill of material just shows the relationship between all the different subcomponents, subassemblies that have to come together to be able to make the end product, which is always going to be at the top. Okay. And for this type of questions, you'll be told how much of each part are needed to make that one last end unit. Okay. So what I see here is that we need 6 parts of B. We need 5 parts of K. We need 6 parts of product subassembly G. Okay. And for part B, B is composed of 2 parts of A and 4 parts of H. Okay. Part K is composed of 5 parts of J and 5 parts of B. Okay. And part G is comprises 3 parts of D, 2 parts of K, and 2 parts of N. Okay. The other piece of information we have here is that they already have some amount of stuff in the warehouse in the inventory already. Okay. So we have 16 parts of B already in the warehouse already made. We don't need to buy them because they're already there. We have 32 parts of A, 22 parts of H, 32 parts of K, and 17 parts of N. Okay. So the first question that you're going to be answering would be similar to this one here. It says, using the information above, how many additional units of B are required to produce 45 end item? So we're going to assume that this question is asking us to produce 45 bikes. Okay. And the question's asking how many additional units of B, given that we already have here 16 parts of B in the warehouse. Okay. So I see we have B over here. I also see B over here. Okay. And typically for a bill of material type of question, it's going to be a straightforward multiplication. You're going to be multiplying down whatever path you have here. So I typically would set this up with the path and the amount of parts needed. Okay. So the first path I see here is from 45 to this letter B here with 6 parts, right? So from the bike to B. And the amount of parts we're going to need here are, you're going to multiply, straightforward multiplication. We need 45 bikes, and each of those 45 bikes are going to need 6 parts of B. Okay. So for that first path, we're going to need for 270 parts total to be able to make 45 bikes. Okay. Our second path to B here is from the bike to K to B. Okay. So that's the second path going straight down here. Okay. And for this path here, I need to again multiply all the way down. So we need 45 bikes. I'll multiply that by, we need 5 parts of K, and we also need 5 parts of B. Okay. So for this second path here, we need a total of 1125 parts. So the total amount of parts that are needed if we are to make 45 bikes will be, if I sum this up, 1395 parts. Okay, so this is our total needed. Okay, but remember we have 16 already in the warehouse. So for you to answer this question, you must subtract the 16. So we have 1395 needed, but we already have 16. So the actual amount that answers this question is that we need 1379 parts of B. Okay. Always remember you have something in the warehouse already. And if that's the case, then subtract that to get your final response. Okay. Now the next question here reads, using the same information above, how many additional units of K are required to produce 45 end items? How many units of K? So find all the Ks that you have on your diagram. I see one here. And I see another one here. Okay, it could be two, it could be more than two. Look for all, and just to make sure we're not confusing this, let me change the color. So that's a K, there's another K here. And I'm going to repeat the same thing we did over here. Okay, I'm going to maybe put a separate table. And the new path that I'm going to have here is from the bike to K. And then the second path I see here is from the bike to G to K. Okay, so starting with the first one that we have here, the bike to K, we need 45 bikes, and each bike is going to need 5 units of K. That's for this very first straightforward path we have here. Now for the second path, we're going to need, again, to make 45 bikes using 6 parts of G, and each part of G requires 2 parts of K. Okay, so multiplying this value here by this value here by this value here. Okay, and I get 540. Okay, so if you combine these two here, the total amount of part K needed will be approximately 765. Okay, but always, again, go back and see, do we have anything in the warehouse already? And in this case, we have 32 parts already. So subtract that and say we needed 765, but we have 32 already available. So the balance that's needed will be 733 parts of K. And that's what you'd put as your solution here, 733 parts of K needed. Okay. All right, and that would answer this question in its totality. Let's move on to question 2. Question 2 is about how do we go about determining flow time, how do you go about determining days past due, and which option would be better between typically the SPT, the EDD, and the FCFS, right? So the shortest priority, the shortest processing time, or the earliest due date, or the first come, first serve sequencing decisions. That's what this question here is going to be about. Okay. So this question here reads, Macy's Auto Repair has a backlog of cars to repair, as described in the table below. So we have 5 different vehicles here, and we're told when they arrived at this repair shop, when the owners expected back, and how long it's going to take to repair those vehicles. Okay, so the first question here says, using the shortest processing time priority sequencing rule, when will repairs to the Tahoe is down here, be completed? And the second question here is, using the shortest processing time priority sequence, what is the flow time for the Avalon? Okay, so let's go ahead and start. And I'm going to do this down here. Okay, and I'm going to add, you're going to need to add an additional 3 columns to be able to answer this question here. Okay, so you need to know for each car, if they started repairing it at a certain time, when do they finish repairing that vehicle? Will it be past due? And what's the total amount of time that car is going to be at this auto repair shop? That's your flow time. Okay, so let's start with this is the shortest processing time rule, right? So you need to answer the question of which column here between these 3 here has to do with processing time, how much time it takes to process this specific product, right? And in this case here, I think estimated repair time is the same as processing time. Okay, so I'm going to sort, and if I don't see you sorted your data, I'm going to deduct some marks for that, because you need to sort your data and have the car that has the shortest processing time at the top. Okay, so highlight your entire table and do a sort. I typically would do a custom sort, and I'm going to sort this table by estimated repair time from smallest to largest. Okay, and you note here that everything is sorted out. The car that goes first then becomes the Malibu. And now you have to fill out the rest of the table. So the finish time for the Malibu, assuming that we started today's time 0, it takes 3 days to repair this vehicle. So we should be done in 3 days' time. Okay. And as soon as we finish working on the Malibu, which is 3 days from now, we are going to start working on the Avalon. And that's going to take 5 days to repair. Okay. As soon as that's done, which is at the end of day 8, we're going to work on the Tahoe. That's going to take 6 days. Okay. Now this formula here can stay, so I'll drag it down. And we have that entire column is complete. We have the finish times for each and every vehicle. Now I can figure out whether or not any of these cars here would be considered as being past the due date, right? We promised our customers they would have their vehicles back by a certain day. These are the days we actually expect to finish repairing the vehicles. So a due date here is our finish time minus the due date we have here. Okay, and that formula stays the same. So I can drag it down. And that gives us our days past due for each and every vehicle here. The Malibu has a -7, meaning that it is not past due. We actually finished early. See, our finish time is 3 here. We promised the customer they would have it back by day 10. So we finished 7 days early. So it's not past due. So change that to a 0. Okay. Our next vehicle, the finish time is 8. We promised they would be done in 8 days. So it's not past due. The Tahoe has a -6 here, meaning that they finished 6 days early. It's not past due. Okay. So with that in mind, now we can calculate the average of our days past due. Because one of the questions I ask is, what's your average days past due? Okay. So here my average days past due, if I use the average function, highlight all these cells here, I get a 2.4. Okay. And the last column we have here is our flow time. And for the flow time, you're just basically interested in how long would this vehicle have been with this car repair shop from the time it was received to the time if we're done working on the vehicle, right? So the time the vehicle was received is given to you here. The time it's going to take to finish working on it is given to you here. So your flow time is a function of your time since the car arrived plus your finish time. Okay, so the Malibu would be with the repair shop for 15 days. The Avalon would be the repair shop for 12 days, and you repeat that with each and every vehicle that you have here. Okay, and at the very bottom, the very last thing that you're going to do for this table here is to get the average flow time. And my average flow time here is 27.2. Okay. So that then will enable you to answer all the questions that were being asked. The first question was about the Malibu, right? So using the SPT priority sequencing rule, when will repairs to the Tahoe be complete? To the Tahoe, not the Malibu. So let's go to look for the Tahoe. The Tahoe is right here. Repairs to the Tahoe will complete by day 14. Okay. But the question is asking how many days after the due date? How many days after the due date? And my answer to that is days past due here shows a 0. So it will not extend beyond the due date. So put the 0 there. Make sure to read what's in this section of your answer. Okay. All right. The second part of this question was using the SPT priority sequencing rule. What's the flow time for the Avalon? Avalon's right here. The flow time is 12 days. Okay. And question 3 says, compare the results above with the results from using a first come, first serve approach. Which option is better? Okay. If you get a question like this, know you need more than one table. So I have a second table here that we're going to use to compare the two. Same exact info, but now I need to sort. This is first come, first serve. So I'm going to sort, custom sort by which vehicle arrived first. Largest to smallest. Okay, so here the Tahoe arrived 17 days ago. So that's going to be processed first. its finish time here is equal to how long it's going to take to process, which is 6 days. Okay. After we're done with the Tahoe, we move on to the Altima. So that'll be 6 days plus 8 days. So the Altima will be complete in 14 days. Repeat it over for the Malibu, repeat it for the Jeep, repeat it for the Avalon. Okay. And then you use this information here to figure out whether you're going to be past due. And your past due is a function of your finish time minus your due date. That formula stays the same, so I'll just drag it down. And any place you have a negative, it means you finished ahead of time. The Tahoe was due to be returned to its owner 20 days from now. We finish in 6 days, so there's no past due here. There's no past due here. Any negative, change that to a positive, to a 0. Okay. So our average past due here is going to be 6 days. Okay. And our flow time is a function of the time since the car arrived plus finish time. Drag this down. And at the bottom here, the last thing you do again is to get the average of what we have here. Okay. And so now we are able to compare the two. And let's go back to the question that was being asked in question 3. Compare the results with the results from the first come, first serve approach. So when you're comparing the results, you're just looking at these two pieces of information down here, the averages. Which option is better? Okay. So I'm going to start with the days past due. With regards to days past due, the shortest processing time approach is better since it has much fewer days past due than the first come, first serve. With regards to the flow time, let's look at the flow time for the, okay. So you notice here the flow time for the shortest processing time is 27.2. The flow time here for the other one is 30. The flow time is just how much total time does your customer have to wait on average for their vehicle. 27 is definitely better than 30. That's almost a 3-day difference. So here again, we're going to go back and say the shortest processing time is also better because customers wait for a shorter period of time. Okay. All right. You could also be asked to do the same, but do an earliest due date. Okay. How you fill out this cells here is very similar. What really changes is what column are you sorting your data by. Okay. So if you get a question asking for the earliest due date, you know you're going to have to sort by whatever column has due dates. Okay. So in this case here, my due date column is there. I'm going to sort smallest to largest. And now everything is sorted by this column right here. Okay. And once you've done that, everything else will be the same as what we just did. Takes 5 days to finish on the Avalon. After we're done with the Avalon, 5 days from now, we will repair the Malibu. It's going to take 3 days to repair the Malibu. And then after we're done with the Malibu, we move on to the Altima and drag it all the way down. Okay. Our days past due here is going to be finish time minus due date. Drag that down. And any negatives, always remember to change those to zeros. Okay. And then down here, get your average. And you're done with that. Okay. Now let's look at the flow time. Your flow time is the total amount of time the vehicle sits with the business. So here it'll be the time since it arrived plus the finish time. Okay. And here again, you need to calculate your average. And if this was part of the question, which it was not, this has the lowest days past due. Its flow time is almost the same as what we had up here. So I'd actually possibly maybe want to go with the earliest due date approach because it could potentially be better. Okay. All right, so that's question 2. Let's move on to question 3. Question 3 is about an MRP record, a materials requirement plan record for the Maisy Jane Apparel Company. And the item that they're looking to plan for here are zippers. Okay, we're told there's a lot size of 180 units. So anytime they need to order additional zippers, it has to be in batches of 180. Okay, the lead time is 1 week. It takes 1 week to receive those zippers. Okay, so let's go ahead and fill out this table. And you're always going to start with this row, the projected on-hand inventory. They start off with 65 units of inventory in the warehouse, and we need to figure out what's projected on-hand at the end of every week here. Okay, so your projected on-hand is a function of how much you had to begin with, plus any amounts received, scheduled to be received, plus any planned receipts if you had any of those. In this case here, that's blank. And then we're going to subtract our gross requirements. Okay, so that gives us our projected on hand at the end of week 1 at 175. This formula doesn't change, so I drag it all the way to the end. Okay, now our goal here is to ensure that we have enough zippers available to whoever's next within the production line, right? So any place where there's a negative, you know you need to receive some inventory. Okay, so the first negative we have is in week 3. So the question you're going to have to answer here is how many units do we need to order? Okay, and keep in mind that you need to order in multiples of 180. Okay, if we just plug in 180 here, we still won't have had enough inventory. So that's not enough. So it means we're going to have to possibly double. Remember, we're going to be doing it in multiples of 180. So 180 times 2 would be 360. And that then gets us back into positive territory. The very next week, we run short of inventory again. So I'm going to order another 180, receive another 180. Okay. And that gets rid of that negative. We have another negative here. So let's go ahead and order another 180 units. Then another 180. And then another 180. And then another 180. Okay. So if we receive in this amount of materials each and every week from week 3 to week 8, we should have enough to provide whatever is required to meet the gross requirements over here. Okay. Now, the last thing that you're going to be doing here is figuring out when your planned order releases are, and that's going to be linked to your lead time here. Your lead time is 1 week. If we needed 360 parts in week 3, it means we need to have placed an order a week ahead of time. Okay, so in this case here, I'm just going to say we need to order a week ahead of time and ensure we have enough stuff going forward. Okay, so that's all that's all that you're going to need to do to answer a question. If you get any questions similar to this one here, just basically ensuring you know how to fill out your table on the basis of the lot size, the lead time, and how much inventory you have on hand at the beginning of any time period. Okay, let's move on to question 4. All right, so question 4 is asking us to try and schedule out these, the daily requirements for highway patrol officers in Bullock County over the week are given below. So you're told you need 4 officers on Monday, 3 officers on Tuesday, all the way to Sunday, you have 4 officers on Sunday. Okay, so we're basically going to try and see where do we schedule these officers, and can we calculate the amount of slack once we've scheduled out all these officers. Okay, So with these questions here, you typically are interested in figuring out when will these officers have the days off and when will they be patrolling and being on the job. Okay. And for this example here, I already filled out the first two rows. So officer 1 and 2 are going to have their Mondays and Tuesdays as their days off, and they're going to work the rest of the week. Okay. So since we needed 4 employees on Monday, so far we have 0. This guy is off on Monday. This guy is off on Monday. We still are going to need 4 employees here. The same for Tuesday. We're still going to need 3 employees on Tuesday. Okay. On Wednesday, these 2 guys will be working, so our requirement drops by 1 to 8. And on Tuesday, our requirement also drops by 1. Everything will drop down by 1 because we schedule these 2 guys to work on Wednesdays through Sundays. Now we can look to see what combination of any 2 days has the lowest requirement of officers. And let's use that to determine when to give officer number 3 a day, the 2 days off. Okay. 4 plus 3 is 7. 3 plus 2 is 5. I think this is the lowest combination we have here. So let's go ahead and give this person Saturday and Sunday off. Okay. And if that's the case, then we still need 3 officers here. We still need 2 officers here. Every other day drops down by 1. Okay. All right, we move on to officer number 4. And here the lowest combination is actually a tie. There's either 3-2 here or 3-2 here. Okay. Now make sure to check the question to say whether or not the Saturday and Sunday rule applies, where if there's a tie, you should have them have their weekend off. I don't see that written here, but it might be there on the module test. All right, so 3-2, let's give this person the Saturday, Sunday off. You could have also possibly given them, you could have chosen Monday, Tuesday as well. Okay, so if that's the case, we still need 3 officers here and 2 officers here. Everything else drops down by 1. Okay, let's repeat the process over again. 2 plus 1 is 3. 3 plus 2 is 5. There's also 2 plus 2, Sunday, Monday, that'll be 4. So the lowest here is 2 and 1. So officer number 5 gets his Monday and Tuesday off. So we still need 2 officers here and 1 officer here. Everything else reduces by 1. All right, we're down to officer number 7. Officer number 6. And here, the lowest combination, there's a 2-1 here. There's a 2-1 here. I'm going to give this person Saturday and Sunday off. Okay, so we still need 2 officers here and 1 officer here. Everything else will reduce by 1. Okay. And for this officer number 7, the lowest combination is right here. 1 plus 0 is 1. So we're going to maintain that. Everything else is going to drop down by 1. Okay. Now we have multiple combinations for officer number 8. You could have Monday, Tuesday, could have this 2 days off, could have these 2 days off, or it could have these 2 days off, right? So I'm just going to give him the weekend off and say that he's going to have Saturday and Sunday off. So we still need 1 officer here and no other officers are needed there. Okay. So once you get a 0, you maintain the 0 all the way to the bottom. 0, 0, 0. See a 0 here as well, 0, 0. That just means that we already satisfied the requirement for that given day. Here we're down to 0. Here we're down to 2. This would be a 0. This would be a 0. Okay. So in this situation, we have a tie either Monday, Tuesday here or Thursday, Friday. And I'm just going to go ahead and just give him Thursday, Friday off. Okay. Everything else is going to be a 0, 0. This 2 here drops to 1. This is 0, 0, 0, Okay. And for officer number 10, let's go ahead and give him his Saturday, Sunday off. And then beyond that, let's see here. For officer number 11, everything here is going to be zeros. Okay. All right. I see a small error that should have been captured right at the very top here. This number here should have equaled the requirement up here. So this should have been 11. This should have been 9. This should have been 8. Or going off of the numbers we have here. This should have been 5 and 4. So that possibly throws our calculations off just a little bit, maybe. Okay. And maybe not. I think we have to maintain the data as is. The only reason I had to make that adjustment was 11, 10, 9. Because I needed to end up 8, 7, 6, 5, 4, 3, 2, 1. On your very last row here, you should end up with at least one space with the number 1 in it. And that's why I knew there was something that was off. Okay. So when I did this, this changed also a little bit. So this 2 here means that I would have to check to see if this was still the lowest over here. Let me just briefly go back. All right, so when we got to 2 and 1, the lowest combination was still here. So that means this drops to 1. The 1 drops to 0. Okay. Now the main change that would then happen would be that our combination for 9 would be either it could do, let's do Monday, Tuesday. Okay. And then beyond that, everybody else is okay. So everything stays the same. Okay. And that would then complete your table. Now the capacity here refers to how many officers did you get on any given day. So that's going to be anything that's not highlighted in a color, that's going to be an officer who's working that specific day. So for Monday, we have 1, 2, 3, 4, 5, and 6. So our capacity here is 6 officers. Tuesday has the same pattern, so that's 6 officers. Wednesday, everybody comes into work, so that's 11. Thursday, everybody's coming in, so that's 11 officers. Friday, everybody's coming in. Saturday, we have 5 officers coming in. And Sunday, we have 5 officers coming in. I'm just counting the number of spaces in white. Okay. So our slack here is the difference between the capacity and the requirement. Okay, so on Monday, we have 2 additional officers more than what we needed. And you can drag that formula all the way to the end and figure out your total slack, your total capacity if you sum up those numbers. So this tells me here that we had an additional 11 officers assigned above and beyond what the company needed, beyond what the highway patrol needed for that week. Okay. So to answer the question here, what's the minimum number of officers required? I'm going to say 11. That is off of the highest count we have here. Okay. How much total slack? Total slack is also 11. Okay. All right. That answers that question. Let's move on to question number 5. Okay. This is kind of a lengthy one. Okay. And this one here will require you to fill out about 4 tables because I see 4 different circles here in the bill of materials. Okay. And the question here is the MPS start quantities for product A call for the assembly department to begin final assembly according to the following schedule. Okay. So they need to make these numbers here are on our MPS right here. 150, 250, 140, 160, 140, 120, and 80. That's the information that you get from this question here. Okay. So the information you have here, this is coming from your MPS, your master production schedule. This is, if this company was making laptops, it's just telling you how many laptops are needed each and every week. Okay, so I need 150 laptops at the end of week 1, 250 at the end of week 2, and so on and so forth. Okay, so your level 0 item here, A here, let's assume here that A here is the number of laptops needed. And to make laptops, you need different subcomponents. So B is one subcomponent, C is another subcomponent, and C requires item D. So you'll see on the tables here that you're going to have a table for B, a table for C, and a table for D. And do these tables in sequence, starting with B. Okay. Now, what's the gross requirements for B? Your gross requirements for a certain activity requires you to see what's above it here. So B feeds A. Okay. So A needed 150. Whatever the finished item MPS start is going to be becomes your gross requirements for that item here. But you have to look at the number in the bubble here. There's a number 3. Okay. So we need 3 parts of B to make 1 part of A. Okay. So instead of just putting 150, I'm going to say we need 150 multiplied by 3. Okay. And I'm going to drag this all the way to the end. All right. Now let's look at the gross requirements for C, because C is also on the same level with B. And C, for every 1 laptop, you need 2 parts of C. So here I'm going to say that C requires, for week 1, 150 multiplied by 2. Okay. Always reference that diagram you're seeing there, because it's going to tell you the number of parts that are needed. Okay. If you miss that, you miss a critical part of this question here. Okay. So we need 300 parts of C in week 1. I think I got it in the wrong cell. Let's move it here. So this would equal 150 multiplied by 2, because that's what we have here. Okay. Drag it all the way to the end. So that now tells you how much whoever is making part C will need to have finished at the end of every week. Okay. Now let's go back to our data that we have here. Okay. Do we have any scheduled receipts for B? I'll have to come here and check. And for item B, there's no scheduled receipt, so we leave this blank. Now let's calculate our projected on-hand inventory. And our projected on-hand is a function of what is your projected on-hand for the previous week, plus any scheduled receipts for that current week, plus any planned receipts, minus your gross requirements. Okay. And that formula that I just typed in here stays would excuse me, would be carried all through for the next 8 weeks here. Okay. And you can even copy this formula here, because the formulation doesn't change for item C. And I'm also even going to drag it down here for our last item here, item D. Okay. All right, let's go back to B. I notice we have a negative 250 here. So that means we're going to need additional inventory. Okay. And we need to get this out of our negative status. So let's go and see what type of lot sizing rule we have. Okay. The lot sizing rule here is a fixed order quantity of 400 units. So we're going to need to place an order for at least 400 units. Okay. And the very next week, we are short of inventory. If we ordered 400, that wouldn't be enough. So we're going to order a multiple of 400, which would be 800 units. And that gets us into positive territory here. Scroll down further, it's C, we need another 400 here. We need another 400 here. We need another 400 here. Another 400 here. And finally, another 400 units here. Okay. Now, since we're expected to receive this product by a certain time, I know that it's going to take, there's a lead time of 2 weeks here. So we are going to need to order this 2 weeks ahead of time. So for example, if we're to receive 400 in week 8, we should have our planned order release in week 6. Okay. And the same for each and every week we have on here. Okay. And that will complete the first table. All right, let's move on to our next table here. And for item C, we're told here your lot sizing rule is lot for lot. The lead time is 1 week. And we're going to use that information to figure out what to order here. So this is lot for lot. Let me put that here again, L for L, lot for lot, meaning you order exactly what you need. Okay. In week 1, we are short 180. So I am going to just order 180 units here. In week 2, we are down 500. So let's order 500. Week 3, we don't require anything. Week 4, we need 280. Week 5, we need 320. Oh, wrong place. We need 320 units here. And then in week 6, we need 280. We need 240 units here. And finally, we need 160 units there. Okay. The lead time that we had in the table there, the lead time here is equal to 1 week. So we need to order stuff a week ahead of time. Okay, if we order 160 here, it'd be ready in week 8. And I'll do the same for each and every week here. Okay, so now we're down to our last item, which is item D. Now, item D, if you look at the diagram up here, feeds item C. Okay, so for everyone, for every amount of product that's required, the number that I see here is a 1. Okay, and you're going to be dropping down your planned order releases. These guys here order from these guys here. Okay, so they'll order 500 parts. And because I see a 1 here, it's just like 500 multiplied by 1. It's the same as 500. Okay, and I'll drag this all the way to the end. Now notice that I drop down whatever values are in your planned order releases here become your gross requirements for what you have down here. Okay, and you'll be multiplying that by whatever value you see in that bubble for that specific item. All right, now let's go back to our data and figure out what lot sizing rule we have for item D. Item D, it says, oh, there's actually some other information that I forgot to include. The schedule receipt for item C, there was 200 scheduled in week 1. Okay, so here we have 200 scheduled. So that means that if that was the case, I should have ordered just 20. Okay, and then that would have been pretty much all I needed to have done here. Let's make sure that that's the case. This is lot for lot. For this would have been 460. All right, so the numbers there are good now. All right, so let's move on to this one here. For the last one here, it's a periodic order quantity. And we're told they have 80 units scheduled to be received. So I need to add that here, 80. What else are we told? We are told that on hand, they have 420 units in inventory. Okay, so with that information, now let's go ahead and fill out the rest of this table. So we have a periodic order quantity approach, and the number of periods that we're going to be dealing with here are P equals to 2. So they're ordering every 2 weeks. Okay. All right, so if P equals to 2, I'll be looking for, and let's assume that we're going to start ordering here. Okay. And when you're ordering here, you're going to be ordering enough to satisfy demand for the next 2 weeks. Okay. So I'll have to figure out how much do I need to satisfy for the next 2 weeks. And in this case here, I have more than enough in the warehouse already, so I'm not going to place an order here. Okay. So I'll move to the next, I'll move forward by 2 weeks and see what do I need to order to be able to get us enough inventory to see us through to the next buy period. Okay. And typically I look at the number in the last week here because it's a combination of this and this here. Okay, so it shows here that cumulatively over 2 weeks, I'm going to need to order 560 parts. Okay, and then I go to 2 weeks later. I'll again look to see how much do I need to get us through the next 2 weeks. I need 520 to get us through the next 2 weeks. And then I'll move on to week 7. And again, here I'm going to need to order 160 to get me through the next 2 weeks. Okay. All right. And the lead time here is 1 week. So we know we're going to be placing an order a week prior to that, 560, 520, and 160. Okay. And that completes this question. Okay, let's move on to question 6. This question here is similar to what we did in question 2, so I'm going to skip it because this would be good exercise to see if you understood what we did in question 2. Okay, because it's asking you to look at this information on different jobs with different processing times, different due dates, days since arrival, and then to try and figure out using the SPT, using the first come, first serve, what's the average flow time, what's the average days past due. Okay, let's move on to the last question, question 7. Question 7 is an MPS, master production schedule question, where we're looking to see, do we have enough inventory to satisfy customer orders? Okay, so we have been given a projection of what customers are going to buy. We've been told what customers have already ordered. And then we've been told in the prior week, we have 60 tacos already on hand. Okay, so my projected on hand here is going to be a function of how many tacos did we already have in the food van, plus was there anything else being made, our MPS quantity. Okay, and then we're going to subtract the larger of either the forecast or the customer order. So I'm going to say the maximum of these two values here. Okay, and I'm going to drag that formula all the way to the end. Okay, so now I see here we have a whole bunch of negatives, which mean that we need to build some inventory. Okay, so to answer question 1, if Big Truck Tacos makes tacos in batches of 50, what should the MPS entry be for the 4th week of production? Okay, so they make tacos in batches of 50. What else are we told? One piece of information not seen here, which I'll have to provide to you, is that what's the lead time? So I'm going to put a lead time here of 1 week. These are tacos. I'm going to say that 1 week sounds about right. Okay, so they need to have 100 tacos made in week 1. They'll need to have, since this is 160 and they're making it in batches of 50, I'm going to say they need to make 200 tacos here. Okay. In week 3, they're going to need to make 100. In week 4, they're going to need to make 150 because they are making it in batches of 50. They're not going to make 120. They're going to make 150. And then another 150 here. 100. 150. And 200. Okay. So to answer the first question here, what should the MPS entry be for the 4th week of production? And that will be here, 150. Okay, after scoring a terrific deal on tortillas, Big Truck Tacos decides to produce 160 tacos in weeks 1. So instead of the amount that we have here, let's assume they're making 160 tacos. 160 tacos. 160 tacos. Okay, let's get rid of everything else here. And now to answer the question, if they make tacos in batches of 50, what should the MPS entry be for the 6th week of production? For the 6th week, so we're down, we need 40 tacos here. I'm going to order 50. We're going to make 50 Here, we're going to make 150. You're going to make 150 again. Here, we're going to make 100. And you're going to make 250. Okay. So for the 5th week, for the 6th week of production, they are going to make 150. Okay. With the same data here, what's the projected on-hand inventory for week 5? For week 5, projected on-hand is going to be 10. Okay. All right. And that's all that we need to answer for these questions here. All right. So I think I'm done. I hope this helps. I'll see you guys next week. Have a great day.